Hey guys, today we're going to continue learning some rules of exponents. So the notes for 56A, we start out with talking about definition of zero and negative exponents. So a to the zero power is actually equal to 1 because anything to the zero power, if I took 4 to the zero power, that would be equal to 1. So if I took x to the zero power, that would also be equal to 1. Okay, the only thing we have to watch out for is that a itself, or the value of x in this case, is not equal to 0 because we can't take 0 to the 0 power. If we do, you'll get an error on your calculator, which actually means it's undefined. Okay, so you cannot take 0 to the 0 power. Okay, an example here would be 5 to the 0 is equal to 1. Okay, what's new here is a negative exponent. And a negative exponent is actually the reciprocal. So if I had, for instance, x to the negative 2 power, we can take the reciprocal of x, 1 to the x, and make it 1 over x squared. Okay, so we never want a final answer to have a negative exponent. So we avoid that by actually writing it as the reciprocal and then making the exponent positive. So it sounds confusing, but once we start doing some examples, you will see it. So 2 to the negative 1 power is actually equal to 1 over 2 to the first power, which is 1/2. Okay? And a to the n is actually the reciprocal of a to the negative n, kind of saying the same thing here, just a little backwards. So if we had a to the n is equal to 1 over a to the negative n, it's just like saying 2 is actually equal to 1 over 2 to the negative 1. Okay? So we're going to go through and do some of these examples. So my first example would be 3 to the negative 2 power. Well, we would write it as 1 over 3 squared, which is 1/9. Okay, 7 to the 0 power, anything to the 0 power is equal to 1. And then 1/5 to the negative 2 power, we can actually take the reciprocal, okay, 5 over 1, or just 5, and raise it to the second power, and that would be equal to 25. 0 to the negative 5 power is actually going to be undefined as well because we cannot take, the way it works, a to the negative n is defined only for the non-zero number a. So write in 9, 0. So it can't be 0. All right, so let's try some. So you can pause the video here and try it and then come back and check it, or you can just kind of take notes along with me. So 2 to the 0, 2/3 to the 0 power is equal to 1. All right, negative 8 to the negative 2 is the same as 1 over negative 8 squared. So we take the reciprocal, we get 1 over 64. Okay, 1 over 2 to the negative 3 is the same as 2 to the third power, which is 8. Because the reciprocal, we just move it to the numerator and then we make the exponent positive. Okay, if I did this one, I use my property and I'd say power to a power, this would be 4 to the negative 4 power, which is the same as 1 over 4 to the fourth, which is 1 over 256. Okay, here we're just going to take the reciprocal, so 3 to the negative 4 on the bottom becomes 3 to the fourth power, which is 81. And this one, we've got the same base, so let's take, if we're multiplying, we're just going to add the exponents. We end up with 6 to the 0 power, which we can simplify to be just 1. Okay, so we're going to mix it together with some of the rules that we've already had in the last couple of days, and we're going to simplify each expression. And we can write our answer using only positive exponents. So example 11, I start out and I notice that I've got a 3 on the outside of the parentheses. Pay close attention to where the parentheses are. The coefficient 2 is going to be raised to the third power. My factor of x is going to be raised to the third power. My y is going to be to the negative 15 power. Now evaluate 2 to the third and I get 8. X to the third, y to the negative 15. Now I have to write my answer with positive exponents, so I'm actually going to take 8x squared as my numerator, and I'm going to move the y to the negative 15 to the denominator because I'm taking the reciprocal and making it positive, so y to the 15th. And that would be my final answer. Your final answer can only have one occurrence of the variable. Okay, now number 12, if we look at that, I've got 2x and it's to the negative 2 power. So I'm going to start out, there's going to be different ways you can do it, but a lot of times I like to start and I look at my negative exponents and I simply take the reciprocal right away. So I've got down on the bottom a -4. I like to keep my coefficients out front. So I've got a -4, and then I've got x squared, and I've got y squared, okay? But I'm going to take the entire 2x and move it to the bottom and make it a positive exponent. So I just took the reciprocal. And then on the numerator here, I've got y to the 5th, okay? So now my next step, y to the 5th stays as the numerator, -4, x squared, y squared. And then I'm going to take my 2 and I'm going to square it, so I'll get 4. And then my x is going to be squared, okay? So now I've got on the numerator, y to the 5th, and then I'm going to multiply, -4 times 4. So I pull my coefficient out front, -16. X squared times x squared, my rule is that I add the exponent, so I end up with x to the 4th, and then I've just got y squared, okay? So my rule is I can only have one occurrence of the variable. Notice I've got y to the 5th and y to the 2nd, so I still need to divide them. My rule is I subtract. 5 minus 2 is 3, so my final answer is y to the 3rd over -16 x to the 4th. Okay, and I would be done with that one. All right, so here's some that you can try. Again, you can either pause the video or you can go through them and check the answers. Okay, the first one is going to be 1 over 4 to the 3rd. We're just taking the reciprocal, so this would be 1 over 64. 14, 1 over 7 squared, which would be 1 over 49. Okay, -3 to the -1 power, just let's take 1 over -3 to the first power, which is just -1/3. Okay, 2 to the 0, that should be easy, just equal to 1. Okay, 1/4 to the 0, that's also equal to 1. Okay, 2/7 to the -2 power. So let's just take the reciprocal, 2/7, the reciprocal would be 7/2, and raise it to the +2 power. Okay, and then we evaluate, 7 would be squared, so 49. And then 2 would be squared, so we would have 4, so 49/4. Okay, here we have the same base, so this would be 2 to the, we're going to add them, so 2 plus, -2 plus -3 would be -5. So now let's take the reciprocal and evaluate 2 to the 5th, and we get 1 over 32. Okay, here we've got the same base again. So number 20, we would get 3 to the -2 minus -3 minus 2 would be -5. So if we write the reciprocal, it's going to be 1 over 3 to the 5th, and that'll give us 1 over 243. Okay. Again, we've got the same base, so -3 minus a -2 is going to be -3 plus 2, so 6 to the -1 power, which is 1/6. Okay, moving on, x to the -4th would just be 1 over x to the 4th. We took the reciprocal. 2y to the -3, the 2 is not to the -3 power, so that stays as the numerator, and then y to the 3rd gets pulled down to the denominator. Okay, number 24, because this whole parentheses is to the -3 power, I can just write 1 over, and keep your parentheses, 4g to the 3rd power. And now I'm going to evaluate, so 1 over 4 to the 3rd, and then g to the 3rd. So we get 1 over 4 to the 3rd is 64, and then g to the 3rd. Okay. Here I look at my expression. I've got y to the -2, so I am going to just write that as, when it writes this as x squared, and then I'm going to take the reciprocal, and then the y squared would be in the denominator. That would be my final answer. Number 26, both the m and the n have negative exponents, so I'm just going to keep my 5 in the numerator, my m to the 3rd, and then n is going to be to the 4th. Okay. And then number 27, we've got this expression and it's to the 0 power, so the whole thing's going to be equal to 1. But we want to assume that f is not equal to 0 and g is not equal to 0, because if either f or g were equal to 0, then we would have an undefined situation. So the answer is 1. Okay, moving on to number 28. Okay, we have the same base. If we take r and we subtract a -4, we end up with -2 plus 4, which is r squared. Okay. Here, x is to the negative 5 power, so we're going to move it to the denominator. The y is already down there, so we've got x to the 5th y squared, and what's left up top is just a 1. Okay, now number 30, we're going to take our x squared and multiply it by x to the 3rd, so we add our exponents, we end up with x to the 5th. Y to the negative 4, and y squared gives us y to the negative 2 power. Okay, so our final answer without a negative exponent is going to be x to the 5th divided by y squared. Okay, all right, get a little bit more complicated. We've got a lot of negatives going on. Sometimes it's easier just to start out and just move the exponents. So just take the reciprocal right away. My 4/3 is going to stay, but m to the negative 2 can move to the denominator as m squared, and n to the negative 2 can move to the denominator as well as n squared, okay? But then now on the denominator, m to the negative 4, we're now going to move that to the numerator because we're taking the reciprocal. And then our n cubed, negative 3, is going to go to the numerator as n to the 3rd. All right, now we're going to divide. So we've got 4/3. We can't simplify that part of the either of the coefficients. We can't divide. We're going to leave it. M to the 4th divided by m squared is going to be m squared because 4 minus 2 is 2. And n to the 3rd divided by n squared is going to be n. So here's our final answer. Okay, number 32, when we do this, we've got 2 h to the 3rd. Okay, again, let's set it up like this. In the bottom, we've got 3jk. All right, but now this j to the negative 3, I'm going to move to the bottom. It's j to the positive 3, and then my k to the 4th is going to stay up top. All right, so now next step, I'll combine. I've got 2/3, my h to the 3rd, k to the 4th. But now I've got j times j to the 3rd, so that's going to be j to the 4th, and then times k. All right, and then my final step, I'm going to divide k to the 4th by k, so I end up with 2h to the 3rd, k to the 3rd, divided by 3j to the 4th. And that's my final answer. Okay, and then number 33, we're going to start that out. Let's see, we've got this 3x to the negative 3. So let's pull that to the denominator. So when we do that, we've got just y to the 4th up top. Okay, negative x squared, I like to keep, so that's going to be on the bottom. My y is going to be move it to the top. And again, we move the 3x to the denominator and we're squaring it. So we just kind of rearranged with the negative, oh, and I'm sorry, it's to the 3rd power. Whoops, it should be to the 3rd, hard to see. Let's erase that. So 3x, okay, 3x, and that's going to be to the, kind of giving me a hard time, 3x to the 3rd power. Okay, y to the 4th times y to the 6th is y to the 10th. Okay, and then we end up with negative x squared. My 3 is to the 3rd power, my x is cubed. Okay, then we're going to pull 3 to the 3rd out, so we get y to the 10th, all over negative 27, because 3 to the 3rd is 27, and then our x is going to be to the 5th power. Okay, so there's our final answer. Okay, all right, so the next section, scientific notation, will continue in the next video.